Hi, I'm Stefan. Welcome to the Two-Stack Developer channel. Today I've got a little bit of special news to share with you. Not only did we make 100 subscribers on the channel, but I'm also going to be releasing a few new features in the Bitcoin for J library shortly. The specific features relate to additions that I'm making to the locking and unlocking script builders. I'll be releasing convenience classes for creating pay-to-script hash, locking and unlocking script builders, pay-to-multisig, that would be naked multisig as opposed to the older multisig that would usually be created using pay-to-script hash. And additionally, I'll be doing a unspendable data lock builder, but my favorite of all of these is the spendable data lock builder, which is called pay to public key hash data lock builder. And that is what we're going to be talking about today. Now, the pay to public key hash script, or rather, let me back up a bit. When we want to send data onto the blockchain, typically until now, what we have done was construct what is known as an op return output. This would be an output in a transaction where the script, the locking script, the first two opcodes in the locking script would be op false followed by op return. These make the output verifiably unspendable. So any satoshis that would have been attached to that output become unspendable. So it's never a good idea to attach satoshis to an op return style output. Now, there is a type of output that we can create within Bitcoin SV only, which is a spendable data output. And in order to create a spendable data output, what we're going to be doing, one of the ways, which is essentially to prepend an op drop to the start of the locking conditions for a pay to public key hash script that will be the locking script for pay to public key hash. Now, if you think through what that does, when the unlocking script or the unlocking condition during script evaluation is attached to the locking conditions, the script evaluation proceeds until it comes to the start of the data push that precedes the drop. So we push the data onto the stack, we drop it off of the stack, it goes away, but now we can proceed with the unlocking or the spending conditions in the normal pay to public key hash fashion as if nothing happened. Now, why is this interesting? Well, since pay to public key hash requires that the party who is receiving the funds sign over the output, we are essentially requiring that party to sign over an arbitrary piece of data that we're attaching to the spendable output. And that is a really powerful method. I can't wait to see what sort of interesting things you think of doing with this. But now to the code. Right, so Bob is going to be receiving the funds, right? Which means that we need to lock, the locking conditions will have to be for Bob. So what I will do is I will create a new locking builder for Bob. I'm still going to say it's a locking script builder, but now I'm going to make a pay to public key hash data lock builder to Bob's address, and I will send some arbitrary bit of data, right? I'm going to say hello world. Let's spell world correctly. And I'm going to encode this to a byte array. And this needs to be wrapped in a byte buffer. Let's import, come on, Stefan, fat fingering. Let's import the Java NIO byte buffer, and that's it. We should be good to go. We should now be able to create a, oh, we've forgotten one thing. Let me quickly fund Alice's, let me send some money to Alice's wallet address quickly to get a UTXO that we can spend from, right? So I'm going to clear this, and I'm already dropping into my Docker container in case you didn't notice. Okay, so the Docker container is the Bitcoin node container which runs the regression test mode node software. If this is the first episode you're watching, then please go watch the previous one about the regression test mode node. Yeah, Bitcoin CLI, send to address. Let me find Alice's address. I'll send some funds to Alice. Oh, we need to say how much we're sending to Alice. I'm sending Alice 10 Bitcoins. And this is her transaction ID. I'm going to ask Bitcoin CLI to give me the raw transaction associated with this transaction ID. This is the raw transaction. I'm going to take that raw transaction. I need to replace that here with Alice's funding raw transaction. Now, I don't want to make the same mistake as I did yesterday, which was to mislabel the indexes of the outputs where in the funding transaction, right? So I'm going to quickly decode this raw transaction just to be able to see which index the money is actually gone through. Okay, it's gone in output number 1, which, if I recall correctly, these are the outputs which we are referencing for Alice, so we should be good. We've now got Alice's raw transaction, and I think we should be good to go. Alice can now spend money from this raw transaction using her private keys because it's received to her address, and we can send it to Bob. So let's run the program and get the raw transaction output from it. Okay, we've got a raw transaction output here. I'm going to go over to the terminal and I'm going to try and broadcast that transaction. Let me clear this. I can say Bitcoin CLI send raw transaction. This is the raw transaction sending to Bob. This is the transaction ID. Just for the sake of ceremony, I'm going to ask for this transaction ID again, even though, sorry, I'm going to ask for the raw come on, Stefan. Failing to type and talk at the same time again. Bitcoin CLI get raw transaction for this transaction ID. These two raw transactions, they're the same. So I didn't really need to do this. I could have just grabbed the one that I sent onto the network and decoded that to see what was in it. But I want to run a sanity check. So I'm going to say Bitcoin CLI decode raw transaction so that I can look and see what the Bitcoin node accepted from me. Okay, so here are the 10,000 Satoshis that we sent to Bob, and look at this now. Okay? The latter part of the script in the first output, indexed 0, which should be looking familiar to you. This pattern here is just what we would normally send as the locking conditions for a pay to public key hash script. So it's opdup op hash 160, a hash of a public key equal verify and check sig. But look at the front here, a bit of data followed by a drop. And that's it. It's as easy as that. In a subsequent episode, we will pretend to be Bob and we will go and try to sign and spend the Satoshis attached to this data. That's going to be interesting. But for now, that's it. Have a good evening or have a good morning wherever you are. I'll see you next time.